Hello everyone, and welcome to the fourth topic in the SS2 First Time Physics curriculum. Now, this topic is about projectile and its application. Now, as part of this topic, we're going to be looking at the concept of a projectile. That is, we define what a projectile is. Then afterwards, we then look at the motion of a projectile. That is, what part does it take? And what does the motion look like, and some other things that we can look that those different parameters you have to consider when looking at the motion of an object. So things like the velocity, things like the height, that is vertical distance amongst other things, and horizontal distance as well. We're also going to look at the time of flight, and now there's an equation that can be used to calculate the time of flight of a projectile motion. We also look at how you can calculate the range, that is the horizontal distance that a projectile is going to cover. Now we also look at the maximum height of a projectile. Then we look at relationship between these three terms: time of flight, range, and then maximum height. Then we close by solving more problems on projectile motion. We're looking at some questions from the WASE exams as well as the UTME exams, and then I'll show you some tips on how to solve questions like that without any error. Now, if you're new to the channel, this is Oya Learn, where we give you educational content that can help you improve in your academics. So if you want to get better, we are your shop log. We are your flawless school tool, where we give you educational content that helps you get better all the time. Please ensure that you are subscribed to the channel and also click the notification bell icon. This way, every time we put out a new content, you will always be notified of it. And we urge you to also help us to reach many more students like you who need helpful videos like this. Now, how you can help us is by sharing the video. It's not going to cost you anything. All you have to do is click the share button. That way, many other people who need content like this will always see it on their own timeline and also join the channel. Now, if you're ready, let's dive into the world of projectiles and its application. First thing we want to look at under this topic is the concept of projectile. That is, we should be able to define what a projectile is. Concept of a projectile. Now, if you're asked what is a projectile, now you have to consider what we have looked at leading on to this topic. We've considered motion in general, where we saw motion of a linearly accelerated body. We also saw motion under gravity. Now, when we now come to what we call a projectile, you see, a projectile itself is actually an object. It's not the motion in particular. So the motion it undergoes may be called a projectile motion, but that object taking that motion is known as a projectile. Okay, so any object that is thrown or launched in air in such a way that it moves under the influence of only gravity. Gravity is the only thing that influences its motion, is therefore a projectile. Okay, when you consider things like a basketball that you throw to try to land into the hoops, amongst other objects that you can launch like a missile, a cannon, amongst other things, they are all projectiles. You see those objects that you launch in air and allow to move under the influence of gravity, they are called projectile. Now let's put that definition down. A projectile is an object launched or thrown in air and allowed to move under the influence of gravity only. So that is, when you launch it and it only moves under the influence of gravity, that object is therefore a projectile. For example, a rocket launched is what? A projectile. A tennis ball hit by a racket is also a projectile. A basketball shot into a net is also an example of a projectile. So you see this, all the examples I've mentioned are objects. A rocket, a tennis ball, a basketball. Now, when you look at the motion that they undergo, they are launched and allowed to go in air under the influence of only gravity. So as a result, such objects are projectiles. Now, please put in the comment section any other object you know around you that is often launched and allowed to move under the influence of gravity. Put them in the comment section. Before we go into solving questions involving projectile motion, we have to first understand what a projectile is. Now, you could be asked to define the term projectile. Now, it's a common misconception that students often think a projectile is actually a motion. No, a projectile is an object. Okay? Now, you see that object that is thrown or launched and allowed to move in air under the influence of only gravity, though sometimes with air resistance. Now, here's the thing. In the calculations you're going to be doing, you are most likely going to be told to neglect air resistance. Now, sometimes air resistance may affect your calculation. Sometimes the effect is negligible. So that is why we often say calculate neglecting air resistance. Because even those projectiles that you want to shoot, you wouldn't want to use them when there's a lot of wind. Okay, so as a result, we often neglect air resistance. But here's the thing. That object that you shoot or that you launch or throw and allow to move in air under the influence of only gravity is what is known as projectile. Now let's put that definition down. A projectile is an object thrown or launched in air which moves only under the influence of gravity. Now, don't forget that sometimes air resistance may be considered, but I don't need to include this because most of the calculations you're going to do on projectile motion will ask you to neglect air resistance. So if you are trying to describe projectile, you can include it, but it is not necessary. Okay? So now that we can define what a projectile is, let's now look at objects that are projectiles. Okay? Remember, projectile is an object, not the motion. Okay? Example. Examples of projectiles are a tennis ball hit by a racket. Okay? When a tennis player hits his tennis ball with a racket, the ball in that case is a projectile because it undergoes projectile motion. Another example would be a basketball shot towards the hoop. Okay? When a basketball player shoots his basketball towards the hoop, the motion it undergoes there is a projectile motion, and the projectile in that case is the ball. So those of you that love basketball, the Steph Curry fans and the likes, that ball, when they shoot it, the ball itself is a projectile. Now, a cannon fired is also an example of a projectile. You could also name other examples such as a rocket that is launched also in space. It's also a projectile amongst other objects. Now, the key thing there is what? The object has to be launched in air. So it's going to move in air under the influence of only gravity. Now, this is because we neglect air resistance. It is there, but it's often neglected. Don't forget, the reason is because most of the time, these projectiles are used when there is less amount of air resistance. You want to ensure that there's no much air resistance to be able to achieve your goal for that projectile that you are shooting, okay? So this is why you can easily neglect it. And most of the calculations you are going to do involve you neglecting it. But air resistance can be factored as well, but it's not a necessity. So if you're asked now, what is a projectile? You know what it is. What I just want you to do now is go to the comment section and drop examples of projectiles that you know. Now let us look at the motion of a projectile. So let's say, for example, a ball is shot at you and then you whack it with your racket. Let's look at the kind of motion that ball is going to undertake. So you're at a certain height above ground. Let's call that H. Okay? And then you hit the ball. What will happen? The ball will then go like this. Now, let me trace the horizontal ground like this. Now, look at this. Okay? This is what we call a projectile motion, the motion of a projectile. Okay? Now, what are the things we can see here? It is moving horizontally and at the same time vertically. And there are some things you observe here. The speed at which it is going horizontally is always constant in this case. So let's call that U. It remains constant. But the speed at which it is coming down is influenced greatly by gravity. So as a result, as time passes, that changes. So you have V1, V2, V3, and so on until it hits the ground. Like this. Okay? Now, what are we seeing here? The first thing you are seeing here is that there are two motions. Two motions. Okay? We have horizontal and vertical. That is, the object is at the same time going horizontally, traveling horizontally, and also traveling vertically. So let's add that here. Two motions at the same time. Okay? At the same time, it is both going horizontally, and traveling vertically. Now, another thing we see here is that, you see, how far this object is going to go horizontally does not affect how fast it is going to fall to the ground. So both motions are independent of each other. Okay? The horizontal and vertical motion are independent. They don't depend on each other. How far it goes does not affect how fast it drops to the ground. There are some objects that will go very far but will drop to the ground fast. Take, for example, when you shoot a torpedo, it will travel a long distance, but it ends up at its final destination at a very short time. The same thing when you fire a gun. It will travel a long distance but land to the ground very fast. Compare that to when you shoot your ball. It does not go so far as the other ones, but it takes more time before it gets to the ground. So you see that they are independent of each other. They don't actually depend on each other at all. could go far and drop fast, go far and drop at a longer time. It doesn't really matter there. And then another thing that we can see in this motion is the path it takes. The path is what? It takes a parabolic path. You see, the shape of this motion is a parabolic shape. Okay, if you are taking it from the ground here, it means if this is your ground level, that parabolic shape will look like this, like a dome. Okay, this trajectory is parabolic in nature, the same thing as this. So all the calculations you are going to do here are centered around what happens when you are solving problems along a parabolic path. So you have to be very conversant with this type of shape. Okay, so this is what the motion of a projectile looks like. Now let's look at things like time of flight, maximum height, and range of the projectile motion. Let us consider the time of flight of a projectile. Time of flight. Okay, now what this means is we want to look at how long will it take for a projectile launched in air to go up and then return back to the horizontal ground. So we are looking at it going up and then back down. Okay, now remember that when we talked about the motion, in this case we said it has both horizontal and vertical motion. So we need to do what is known as the component of the horizontal velocity and the component of vertical velocity. Now the velocity itself can be denoted v or u. Okay, so to get the vertical component and the horizontal component, this is what we use. Now v of y, which is vertical component of velocity, is actually the original velocity itself, then sine theta. Now you recall this for when we talked about components of a vector, right? Remember that the vertical component is always the original vector sine theta, and then the vertical component is this. Then for the horizontal component, it is the vector itself multiplied by cosine of theta. That is v of x will then be u cos theta. Okay, now look at this equation itself. From v equals u plus or minus gt. We also have another one where we have h equals, now consider this one says ut plus or minus half gt squared, and then v squared equals u squared plus or minus 2gh. Now, which of these most likely help us to find the time of flight without error? Now, when you launch a projectile, some of the things you know that is certain there is the initial velocity, acceleration due to gravity, and then you can also get the height. Because when you know the height, you can know the velocity at the maximum height. We already know that the velocity at the maximum height is 0. Okay, so applying that, we can use this to find an equation for time of flight for a projectile. So in that case, we are considering the y, that's the vertical displacement. So we call that v of y. Now applying that, we're going to be having u t. Now u here is vertical velocity we are looking at. The vertical velocity is the vertical component here is what? U sine theta. Okay, after u, then we have t here. Okay, now since it is moving up, we apply the negative sign. Okay, now the next thing we have is what? Half gt squared. Okay, now this t here, let t equals time of flight t. So if we take this as time of flight, we can then use it to find an equation for time of flight. Now, what do we do at this point? Remember that this is vertical velocity. At maximum height, vertical velocity is 0. Okay? So, at max height, v of y equals 0. So we can then rewrite this and say 0 equals, now this is basically ut. I'm now using the capital letter T since we are solving for time of flight. So ut sine theta minus half gt squared. Now this looks like a quadratic equation. So let's try to solve it that way. So when we take this to the other side, it will become positive. So half gt squared minus ut sine theta, then this plus 0 all equals 0, where a is what? Half g, b is negative u sine theta, and then c is 0. Now we can apply the formula method and try to solve this, right? So using formula method, t equals what? Negative b. So minus, then what is b? Minus u sine theta. Then plus or minus the square root of b squared. B squared is what? Minus u sine theta in bracket squared minus 4ac. So 4, what is a? A is what? Half g. And then c is what? 0. And then all of this divided by what? 2a. 2a is what? Half g. And just like this, we have something that can help us find the value of t. So let's tidy this up and see what we get as our answer. Okay? So from here, we can now see that t equals what? Minus times minus, we get plus u sine theta. Okay? Now, plus or minus, what do we have here? To take care of this, you're going to be having u square sine square theta. Okay? Now, all of this divided by 2 cancel 2, we have g. Now, when you work with cases like this, the negative value does not work for us. So we are only going to take the positive value. So we have u sine theta. Now, when you take the square root of this, you also have now plus u sine theta, all divided by g. Now, why does the negative side not work for us? Because if we take the negative side, because this is plus or minus u sine theta, the negative side will give you minus u sine theta. Now, u sine theta minus u sine theta will give you 0. And all of that will land in 0. So 0 cannot work for us as time of flight. So that is why you see we are using the positive side now. Okay? If you use the negative side, you will get 0. So the positive side is what gives us an equation to work with. So when you add this, what do you have? T therefore becomes u sine theta plus u sine theta. That will give you 2u sine theta. Okay? All divided by what? G. So anytime you're asked to find the time of flight of a projectile, you can simply use this equation. 2u sine theta over g, where t is time of flight. Okay? That is the time it will take to go up and down. U is initial velocity. Okay? G is gravitational acceleration. And then theta is angle of projection. And with just these 4 elements, you can calculate your time of flight. Let us now apply the equation for time of flight of projectile motion to solving this question. The question itself says, a stone is projected at an angle of 60 degrees and an initial velocity of 20 meters per second. And we are to determine the time of flight, taking gravitational acceleration as 10 meters per second squared. Okay? Now, when you want to solve a question like this, all you need to do is apply the equation, put in the proper parameters, and you should get your answer. So let's do that. Solution. What is the equation for time of flight? It says t equals 2u sine theta over g. Okay, so let's apply this. That means we have what? 2 multiplied by u, which is what? U is given here as 20. Now multiplied by sine theta, which is 60 degrees, all divided by g, which is 10. Okay, now t becomes 2 times 20, that gives you 40, times sine 60, that is 0.866. Now some like to leave their answers in this case in short form. That will be short 3 over 2. It's still alright if you do that, as long as you solve everything till the end. Now all of this divided by 10. I can easily break this and say 10 here 1, 10 goes here 4 times, right? So that leaves us with 4 multiplied by 0.866. So the value of time of flight is therefore 4 multiplied by 0.866. That will give us 3.464. And time is measured in seconds. So the time of flight for this projectile is 3.464 seconds. And that's the solution to this question. In this question, we are told a body is projected at an angle 30 degrees to the horizontal with a velocity of 150 meters per second. And we have to calculate the time to reach the greatest height, taking g, which is gravitational acceleration, as 10 meters per second squared, and we are to neglect air resistance. Now, here's the thing. You see, when you consider projectile motion where you are neglecting air resistance and then other things remains the same, most of the times, the time it takes it to reach the maximum height is half of the time it's going to take to complete the motion. Okay? But you know how we do here now. We'll first show you why it is like that before we then go on to how you solve questions like this. So let us prove that equation first, and then we go on to solve this particular problem. Okay? Now, remember that when we were trying to derive time of flight earlier, we considered the horizontal distance that it takes, which is why we took y equals ut plus or minus, of course, half gt squared. We looked at horizontal distance. Now, what we are looking at is just the vertical motion, because it's just going all the way to the top, where it's going to remain stationary before it starts dropping, right? So we're going to consider just that part. So, and the equation to use for that is this, okay? We're going to apply v of y equals, now it's going up, so u of y minus gt. Now, note that v of y equals 0 at maximum height. Is that not so? And then u of y is actually u sine theta. U sine theta. Okay? So now that we have this, let's put it into the equation and see what we get. Okay? Now, that means 0 equals u sine theta minus gt. And then from here we can say gt equals u sine theta. Now, let's bring this up here. Now, time of flight, t here. Time to reach maximum height, rather, t, would then be u sine theta over g. Now, compare this with the original equation for time of flight. You will see that, note, t is actually half of time of flight. Now, let's show that here. So, because t is what? 1 over 2 of 2u sine theta over g. If you look at this here, you see that half, this 2 here cancel this 2, leaving you with u sine theta over g. So you see now that if we had just started with that, where this time we are looking for is half of the original time of flight, that would have been fine. But this is the equation that proves what we just said. So now that we know it's true, let's then apply it to solve the problem. So the time we are asked to find is this small t, and it is u, 150, multiplied by sine theta, Theta is what? 30 degrees. All divided by 10. Now, what does this give us? We have 150 multiplied by 0.5, which is sine 30, all over 10. Okay? 0 here cancels this 0, so we have 15. 15 multiplied by half, and that will give us 7.5 seconds. So the solution to this problem is 7.5 seconds. Now, don't forget, you can practice with many other questions regarding time of flight of projectile motion. And if you should come across any challenge, please don't hesitate to put that question in the comment section, and we'll attend to all of your comments. Now, if you're yet to be subscribed to the channel, this will be a good time to take a moment to click the subscribe button, and also ensure that you click the notification bell icon so that every time we put out a new content, you will always be notified. And don't forget to help us to reach many more students like you who need videos like this by sharing the video. All you need to do is click the share button, and just like that, we expand our family and continue to help many more students like you become better a day at a time. Thank you so much. Now let's go to the maximum height. Let us now consider the maximum height of a projectile. Now, the maximum height refers to the highest vertical distance that a projectile will travel. Now, how can we solve this? Okay, to get an equation for this, remember we are dealing with what? Maximum height. Maximum height. Okay, to get an equation for the maximum height of a projectile, we'll start our equation from the third equation of motion under gravity. Now, that equation says V equals V squared equals U squared plus or minus 2GH. Now, this H here is the maximum height. Okay? And this is a vertical motion upward. So we're going to use the vertical component of velocity. So since H is vertical, okay, we are going to apply the vertical component of these motions. So we're going to be saying V of y squared equals U of y squared. And it's going up, so it will be minus 2GH. I hope you understand what this means, right? Okay, so from here now, what do? We know that at maximum height, the velocity is going to be 0. So that is V of y is 0. And you see this U of y, the vertical component of the initial velocity is supposed to be what? U sine theta. So let's put all of that here. That is V of y equals 0. And U of y is U sine theta. Okay? So since we have this, let's then plug it into the equation. So from here we can now say 0 squared equals U sine theta squared, okay, and then minus 2GH. So now we have this. So what do we do from here? I would like to take this to the other side so it can be positive, and then we can make H the subject from there. So when we take it to the other side, you then have 2GH equals, now when you square this, what do you get? You get U squared sine, now it's sine theta squared, but when you do that, you can get confused. You might think that you are squaring just the angle. So when we write this, we often write sine square theta, meaning that you first find sine theta before you square your answer. Okay? So from here, if you make H the subject, you then say H, which is the maximum height, will now be U squared sine squared theta. Okay? And then, now you divide both sides by what? 2G now. So this has to come down. So all over 2G. Don't forget, U here is the initial velocity, theta here is the angle of projection, and G is the gravitational acceleration. So if you are asked to find the maximum height of a projectile, you apply this equation. This question says, an object is projected with a velocity of 80 meters per second at an angle 30 degrees to the horizontal. The maximum height is, so that is, we have to find the maximum height taking gravitational acceleration as 10 meters per second squared. Now, you already know the equation for maximum height, so try to apply it to solve this question. And then compare your answer with what is gotten at the end of this video. And don't forget to leave us a comment if you got it right. Now, let's see what you did. Now, the right way to go for this is to apply the equation maximum height equals u squared sine squared theta over 2g. Okay? So, to apply this equation, what do we have? U is given as 80. So, that is 80 squared sine. Now, the angle is what? 30 degrees. Now, we square that as well. And then we say all divided by 2 times 10. Now, let's break this down gradually so we don't have any issue. Okay? H here therefore becomes, this is 80 times 80 times. Now, sine 30 is 1 over 2 times 1 over 2. All divided by 2 times 10, that gives you 20. Now, this will give you 8 times 8 is 64. So 6400. Now, this will give you 1 over 4, but we can break it down and say 4 times 20, which means we have 6,400 divided by, now this will give you 80. Okay? 0 cancel 0. Okay? 8 here 1. 8 in 64 is 8. Then the 0 comes here. So that is maximum height h therefore becomes 80 meters. Okay? Now, I hope this is what you got at the end of your own calculation. If you did get it right, put in the comment section, I got it correctly. In this question, a stone propelled from a catapult with a speed of 40 meters per second, attaining a height of 20 meters. Now, we have to calculate the time of flight and the angle of projection. Now, when you want to use the equation for time of flight, you are required to use the angle of projection in that equation. And since we don't know the angle of projection yet, it means we have to solve for that first before we can get time of flight. Now, we know the height attained already, so we can use the equation for height to find the angle of projection. So let's go that route. Now, this is what you get. Solution. Height is u squared sine squared theta over 2g, right? And the height given here is 20 meters. So 20 equals u. U is 40, so 40 squared sine theta. Remember, sine squared theta over 2 times 10. Okay? Now, 2 times 10 is 20. Now, cross it to this side. You have 20 times 20. That will give you what? 400. Equals, now this is 1,600 sine square theta. Okay? From here, make sine square theta the subject. We then say sine square theta equals 400 over 1,600, which is basically 1 over 4. Okay? So, if this is 1 over 4, we can then find sine theta. So, sine theta would then be the square root of 1 over 4, which is basically 1 over 2. That means theta is sine inverse of 1 over 2. Now, sine what will give you 1 over 2? That is sine 30. So, the angle of projection is therefore 30 degrees. Now, that's for the B part. We now know the angle of projection. So let us apply that to find the time of flight. Now, for time of flight, t, that is given as 2u sine theta over g. That is, we have 2 times, u is what? 40, times sine 30 degrees all over g, which is 10. So t therefore becomes, when you multiply this, you get 80. 80 divided by 10 will give us what? That will give us 40. So 80 divided by 10, that should give us 8, I mean. Okay? So we have 8 multiplied by sine 30 degrees. So we have 8 times 0.5. Now, there we go. So the time of flight t is therefore 8 times 0.5 is basically 8 times half, and that will give us 4 seconds. So you see, the time of flight is 4 seconds and the angle of projection is 30 degrees. Now apply this to other questions that you can find on projectile motion, I mean. So try to find time of flight, try to find the maximum height attained. And sometimes use the maximum height to also find the angle of projection, as we have done, and also try to use time of flight to find the angle of projection. Now let us go to how you can find the horizontal distance that a projectile travels, otherwise known as the range. Let us now consider the horizontal distance traveled by a projectile, otherwise known as range. Horizontal distance of a projectile. Okay, so when you shoot a projectile and then it travels an horizontal distance, remember it will go along a parabolic path and end up at a point, which is a certain distance from the start point. Now, how can you find that? Now, you agree with me that the range r, therefore, is supposed to be the speed times time, because speed is distance over time. So that will be horizontal speed multiplied by time. The time here is time of flight. Okay? So sometimes you could be asked to find the relationship between time of flight and range. It is basically horizontal speed times time of flight. Now let's look at what all of this mean. So range itself would then be what? What is the horizontal speed? That's horizontal component of speed. It will be what? U cos theta multiplied by time of flight. Okay? But, okay, we know that time of flight is 2u sine theta over g. So let's apply that here. That will mean range equals u cos theta multiplied by 2u sine theta over g. Now there's something you will see here. Okay, something called trigonometric identity. You see that r here equals, okay, from what we can see, u and u. Then we have 2 sine theta cos theta. So the u multiplied by u will give you u squared. Now we have 2 sine theta cos theta all divided by g. Now, what I call that trigonometric identity, there's a trigonometric identity for 2 sine theta cos theta. Whenever you have something like this, it's the same thing as saying sine 2 theta. So I can replace the whole of this with just sine 2 theta. So let's do that. That would mean the range would then be u squared. Now all of these become sine 2 theta all divided by g. So this is the equation that can be used to solve the range of a projectile. Now, let's look at this. If the army is supposed to shoot a missile at enemy camp and they know the distance, all they need to just adjust the angle of projection and they should be able to hit that exact distance by using this equation. So, you know the distance of your enemy, you can calculate the angle needed. If you have set it to an angle, you can calculate the distance that particular projectile will get to on the horizontal plane using this equation. And sometimes if what you have is time of flight, you can also apply u cos theta multiplied by the time of flight that you already have. Now, all these equations here, this and this, are effective whenever you are solving for the range of a projectile. Let's now apply it to some questions so that you see how it is used. A stone is shot from a catapult at an angle 30 degrees to the horizontal. If the speed of the stone when shot is 30 meters per second, find the range of the stone. That is the horizontal distance the stone is going to travel. Now, here's how you solve this. The range is u squared sine 2 theta over g. Now, u is given here as 30, so 30 squared sine 2 times 30 degrees, all divided by, now we are taking g to be 10 meters per second squared. Now, once again, when solving problems like this, you are going to be given the value of g. Okay, I'm using the value 10 meters per second squared just so that it could make the calculation a lot more easier, okay, for those that don't use calculator too often. However, know that sometimes you could be given other values such as 9.87 amongst others, which also represents gravitational acceleration at different points. Okay, so let's continue with this. R is therefore 30 squared, that will give us 900, multiplied by sine 60, all divided by 10. Now, what does this give us? This would give you 90, and sine 60 would give you sod 3 over 2. Now, the range is therefore 90 divided by 2, that will give you 45 sod 2 in meters. Now, you can go ahead and use your calculator to find the final value of this, but even if you leave your answer in short form like this, it is accepted. So this is the solution to this question. In this question, we are told that the range of a target is found to be 20 kilometers, and a shell leaves a gun with a velocity of 500 meters per second. Now, what must be the angle of elevation if the ground is level? So we want to find the angle of elevation, that is the angle of projection. Okay, so here's how you solve a question like this. We are using the equation for range, which is u squared sine 2 theta over g. Okay, now the range is already given. In this case, that's 20 kilometers, and 20 kilometers is 20,000 meters. So 20,000 equals 500 squared sine 2 theta all over 10. Okay, from here, if you cross multiply, you then have 200,000 equals, now 500 squared will give you 250,000 sine 2 theta. Okay, now let's take this here. That will mean sine 2 theta is what? 200,000 divided by 250,000. Let's break it down. This cancels. Now 20 over 25. What goes here? 4 goes here. 5 goes here 4 times. 5 goes here 5 times. Okay? So sine 2 theta therefore becomes, this will give you 0.8. Okay? Now from here, we can make 2 theta the subject and then find the sine inverse of 0.8. And then 2 theta here would give us, now sine inverse of 0.8 would be 53.13, thereabout. Okay? Now from here, we just have to divide both sides by 2. And then we'll find that theta is what? 2 in 5, that is 2. Remember 1. In 13, that would be 6. So remember 1, so point. In 11, that would be 5. Remember 1. And then in 13 it will go 6 times. Remember 1, so that is 5 in degrees. So theta would be approximately 26.6 degrees. And this is how you solve for angle of elevation when you have the range, you have the initial velocity, and gravitational acceleration. There's one more thing that you need to do about projectiles, is that you can know the maximum range of any projectile. There's a specific angle at which every projectile will be able to produce their maximum range. Now, you know that range depends on a number of factors such as the initial velocity, gravitational acceleration, amongst other things. But the maximum range occurs at a specific angle. So let us determine that angle as well as develop an equation or determine the equation for the maximum range of a projectile. Now, we know that the range itself is what? U squared sine 2 theta over g. Okay? Now, sine of angles is maximum at 90 degrees. Okay? When you consider sine of angles, you see sine 0 is 0. As you begin to increase the angle, the value continues to increase gradually until you get to 90 degrees, where you are going to get 1. Now, by the time you start going from 90 down again, it starts reducing until you get to 180. And it continues like that until you get back to 0. Okay? So all of this applies. Okay? Now, let's see what happens at this case. Since we know this is 90, we have to find a way to make this 90. So that means range is maximum when 2 theta equals 90 degrees. Now, this implies that theta will become 90 degrees divided by 2, which will give you 45. Okay? So if you apply 45 degrees in this, you then see that R max becomes U squared sine 2 times 45 all over G. Now, this will give you U squared sine 90 degrees over G. Now, sine 90 is 1, so that means maximum range, R max, would then be what? U squared all divided by G. So if you're asked to find the maximum range of any projectile, you can always apply U squared over G. And sometimes some questions may be twisted such that they tell you that the projectile achieved its maximum range. In that case, just know that the angle of projection is 45 degrees. So whether you're asked to find time of flight or the maximum height of such projectile, apply your angle theta to be 45 degrees. Is that clear now? Now, what I want you to do is practice more with what we have done so far. You see, the thing about physics is that the more you practice, the better you get. So please find more questions around you, attempt them, try them out, ensure you solve them. Now, if you come across any challenge while you are doing this, ensure that you put it in any of the comment sections of our videos. And we promise that we'll attend to all of your comments. If you're yet to be subscribed to the channel, kindly do so. Click the subscribe button and also the notification bell icon. This way, every time we put out a new content, you will always be notified. And please help us to reach many more students like you to get better daily by sharing our video. You can do this by clicking the share button and then share it across your social media channels. This way, all your friends get to see it and then they can also find our channel and also improve daily. Thank you so much for following the video so far. We continue in our pursuit for knowledge. We don't stop. You know now. I'll be seeing you in the next video. Bye for now.